Hello everyone from wherever you are in the world. Hope you're all having a fantastic day. Welcome to today's live stream. We're going to be continuing our ongoing series. We're looking at some generative design in Fusion 360. We were going to be doing some looking at rendering today. We've decided to move that a few weeks forward, so we will be coming back and looking at how we can set up and create some really nice renders of generative design parts, and we're going to be doing that in a few weeks time. But instead today we're going to be taking a look at some of the files that are inside generative design, which are the generative design samples. I know some of you have been wanting to get hands-on with some of the files that we've been using, so we've heard that you've been saying that, and we're definitely hoping to share some things with you in the future. But for now, we're just going to show you these generative design samples so you can get hands-on with generative design yourselves.
So as ever as well, feel free to put any questions down in the chat. I'll be monitoring that all the time. As Pete said, because we're going through these and you can do it a bit more hands-on, we're expecting that there may be a few more questions coming in. So if you're following along and you're just not sure about something, feel free to put that in the chat.
Cool, fantastic. Yeah, and we might be a bit shorter than we have been this time. We're expecting it'll be a bit of a shorter stream, but hopefully we'll still get some good stuff. So we're going to go right ahead and jump into Fusion as we have been doing. And what we're going to be doing today is taking a look at the example files that everyone who has Fusion 360 is going to have access to. And you can reach these files by, if you open your data panel in the kind of top left hand corner, you have these kind of 9 squares, which are your data panel, and you'll see your project files that you have, your project folders that contain, CAD data, folders, etc. And then if you scroll down, everybody has included these kind of sample files, and these are really useful just to kind of get going with certain aspects of Fusion 360. So you can see we've got some simulation samples, we've got some electronic samples and design samples. There's these files called workshops and events, and often these will relate to certain like online tutorials and things like that, which can be quite useful. But we're going to go ahead and open this folder here, which is the generative design samples. Just make sure you can see where I'm clicking. So we're going to open up this folder here, and what you'll get inside of here are a bunch of different generative design example pieces at various stages of the kind of generative design workflow. So at the top folder you'll see here is called outcomes, and if we open this up, we've got basically some examples of downloaded outcomes from inside of generative design. We also have this folder here called Ready to Explore. And this is where we've set up for these different case studies all the information that we need to run a generative design study. And that's the things that we've been looking at these past few weeks. So setting up our preserve and obstacle geometry, setting up our forces, deciding which objectives we want to run for our study. And everything in these will be already set up. So if we open one of these, we will see all that information already in there. And all we have to do is press generate to generate outcomes. And then lastly, we've also got this us. So I actually misspoke slightly there. So this ready to generate will be already set up, ready for us to generate. But then this folder here called Ready to Explore will be files that we've done all the setup for generative design, we've generated those outcomes, and we can actually open one of these up and we can go in and explore ready generated outcomes that have been created beforehand. So if I open one of these up, so if I open up Explore GE Bracket, this is a project file in Fusion 360 with the entire generative design study set up. So we can see we've got our obstacle and preserve regions. And this file here is actually a It's called the GE bracket, and this was actually done as like an open source design challenge by GE. And what they were doing is inviting CAD users. Anyone could apply and take part in this competition, and they had to take this bracket here that you can see. So this was the existing design of, it's for a kind of aerospace application, and what they were doing is getting people to redesign this bracket and make it as light as possible. So, you know, hundreds of people from all over the world took part in this competition, redesigned this component based on the requirements that GE had described. So things like it has to withstand a certain amount of forces and load cases, has to be made of certain materials, and they used their kind of CAD program to reimagine what this could look like. So I'm pretty sure there'll still be some results out there and you can go and see some of the designs that people created, some really kind of wacky shapes, but some of them really, really high performing. So what we've done here is set that up as a design study in generative design. And what generative design is going to do is kind of similar to getting, you know, hundreds of different designers from all over the world to come up with designs, but we're going to use software to come up with those hundreds of different design possibilities instead. And so what we've done is we've created you can see the obstacle and preserve regions for this bracket. So we're saying we need to keep these connection holes clear, we need to have a flat base, and we need these connection points to the base, and that's what essentially this obstacle and preserve geometry regions are. We've then got our different load cases, and again these are going to be those prescribed load cases that represent the different forces that are going to be acting on this bracket that it needs to be strong enough to withstand. And we can see everything that's been set up here. We can also see the objectives that we used. So in this case we ran minimize mass with a safety factor of 2, and a couple of different manufacturing methods. So we've only really explored 2 in this case, so the additive constraints and the unrestricted outcomes. And the fewer manufacturing constraints that we decide to explore, that's going to affect the number of results that we get out the other side. So by including additional manufacturing constraints, we could have actually got many more different possible outcomes. And then lastly, we've got just a range of different materials that we want to explore. And like we said, this is a study that's already been set up and ready to explore. So any of you that have Fusion 360, you can go to this folder, you can open up the same file that I'm looking at here, which is Explore GE bracket. And when we go to this Explore window, we're going to see all these results that have been generated by Generative Design. Okay, so we've got all these different outcomes. The number of outcomes you get is not a random number. It's actually prescribed by the number of materials you select and the number of manufacturing conditions. So when I select an unrestricted manufacturing constraint, I'm going to get a single outcome that is unrestricted for each one of my materials. When I select additive manufacturing as a manufacturing constraint, I'm actually going to get 3 different outcomes for each one of my materials. And the reason for that is that when we think about additive manufacturing, we need to think about the direction that our part is being built in. So additive manufacturing, we build our design layer by layer. Starting from a flat base plate, we slowly build our design up. And the direction that we build our design in is going to affect things like our overhang angle. So we actually create 3 different designs where we design it as if it's going to be built in the positive X direction, the positive Y direction, and the positive Z direction. So if we look at just one single material, so if we look at titanium, we can see we've got 4 outcomes for titanium. A single unrestricted outcome, and then 3 additive outcomes. And we can see it's additive because we've got manufacturing method additive, and we can see that the orientation is X plus, Y plus, and Z plus. So if we open up our Z plus additive outcome, like this, what we'll see is, so we have essentially tried to design a component that's going to be built in an additive process, start in this direction here. So we are building it in Z plus, so I can see my Z axis here. So we're starting from a flat base at the bottom of the part, and then we're looking at this overhang angle here and ensuring that this overhang angle doesn't exceed a certain dimension, and that's something that we'll have specified earlier. And that means we can design this component to be printed without needing any support material. So when we use an additive manufacturing process, especially a process like metal additive manufacturing, so in this case we'd probably be using like a metal powder bed additive manufacturing technology to print this in Ti64. And when we use that kind of process, we need to create support material to help overhanging geometry remain stable during the manufacturing process. And after we've manufactured this part, we then need to manually go away and remove that support material. And this is often done just with, kind of like hand tools. So you can imagine that process can take a long time and really add to the cost of these components. So if we can design parts which require as few supports as possible, that's a big advantage, and that's exactly what generative design is looking to do. So if we go out of this outcome view, as I said, if any of you are interested, you can open up Fusion 360 and you can explore this yourself. And I'd recommend you just get a feel for how these different manufacturing constraints can influence the design. Sometimes you'll see some kind of quite strange shapes coming out of generative design. And if you see something that's like a bit unexpected, the first thing, or one of the first things I'd always recommend looking at, is what manufacturing method was used to create it, because that can really explain why the part is the shape that it is. Okay, so again, we can compare these different outcomes against each other on a graph. So what we were trying to do with this setup was create a design that weighed as little as possible. So in this case, we can see on the bottom here, I've got my materials. And these are the different colors on this graph. So I can see my titanium outcomes and then the various steel alloys that we're exploring. And I can see that my titanium alloys are lighter than these ones based on their position on this x-axis of the graph. And I can actually see that this design here is our lightest design. And this design here is also a very low weight. So if I open up one of those outcomes, if we're trying to create a really lightweight design, then something like this one might be the best design based on the load cases we're interested in. You see this design is it's quite shiny, and that's because we're viewing the design preview. So we actually put like a material appearance onto the design while when we're viewing the design preview. I can change that to see the model view. Sometimes these design previews make the part a bit hard to see what's actually going on. So sometimes I like just putting this matte finish on just so we can see what the shape is. Okay, so. And if we want to look at what one of those designs looks like downloaded, we can open up this outcomes file here, and we can open up, you can see outcome 1 GE bracket, and this will show you what this generative design outcome is going to look like once it's finished. So this is that same outcome downloaded inside Fusion 360. If we look at the body, we can view the properties. And this is going to give us information about things like the mass, the volume, and it also tells us what the physical material is. So we can see that this is one of those steel alloy designs. And this is just bought directly across from Generative Design. So when we download an outcome from Generative Design, all that metadata is just going to be brought along as we download it. And I also want to show you, we spoke a little bit in previous weeks about how we can edit some of these designs, and we looked at one of what we call our 2.5 axis outcomes, which is another manufacturing constraint that creates really highly optimized designs, like simple designs, relatively speaking, that are easy to manufacture with a process like CNC machining. And we talked about how we can go back on the history bar and edit those designs using kind of sketches. So when we have like a more free-form design like this, just move Pete again. He's getting some good exercise today. We obviously don't just have single 2D sketches to define this shape. We've got this really free-form organic shape. So what we use to edit these shapes is what we call T-Splines. So you can get into the kind of T-Spline modeling environment. You might have seen that already with the create form. And when you go into this environment, you can make free-form organic changes to shapes. So if you look at the history timeline for one of these downloaded outcomes, we can see that we've done various things. If I just drag this all the way back. So the first thing we did was we brought in all our preserved geometry. And we need to make sure that this geometry is kept accurately in our final design. The next thing we did is we brought in our obstacle geometry. Again, we can see that. So this was like our starting position. And then we bring in the generative outcome and we superimpose that onto the design here. And you'll notice the generative outcome is, if I hover over that, it says organic. The icon is the same as my create form environment. And what that means is that this is a T-spline entity. So if I double click on this, which I'm going to do shortly, we can actually go in and do T-Spline modeling on this design to make free-form changes to the design. So if I keep dragging this along a bit more, you'll see what we're going to do is what we need to make sure is that this final design accurately contains our preserved geometry and our obstacle regions, and it doesn't interfere with those. So what we do is we do a couple of Boolean operations to make sure that we Boolean add our preserved regions and subtract our obstacle regions. And all this does is it just cleans up our design, and it makes sure that we have like a nice clean surfaces and faces, which are just taken directly from our preserved faces and geometries. So what I'm going to do is just drag my history bar back, and I'm going to open up this T-Spline modeling environment. So here we can see the T-Spline model of my design, and we might do a more in-depth look at dealing with these kind of shapes. Again, if you're not familiar with these, there's some really great tutorials online which will show you how to model and manipulate T-spline shapes. But what we essentially have are like a series of splines, and these splines define our 3D geometry. And we can, if we go to this edit form environment, we can manipulate these splines in 3D space to make changes to our design. So if I grab one of these edges, for example, and we move that edge, we can see that our shape is changing. Now, I don't want to introduce like a sharp crease into this design with that process. So I'm probably going to want to select these faces. And the other thing that I'll probably want to think about is creating what we call a soft modification. And what this is going to do is it's when I move this shape here, So when I move these faces, it's also going to move the faces around them, but it's going to spread that movement evenly around the model. And that's just going to make sure that we're making changes to this design that are kind of smooth and keep the overall organic form of the design. So this can be useful. For example, if I look at this shape here and I think I just want to add a little bit more mass to this, then it's quite easy just to kind of grab some of these faces and just manipulate them outwards to increase the overall mass. Again, this is really designed to make edits to your final design. We don't want to be producing our entire shape with this method. But if you see a generative outcome and you like most of what's there, but you just want to go back and make a few small changes, then this T-Spline modeling for environment can be really, really useful. And then if I move back, we can see that we've made that change to this design. We've got a fully updated solid model, and our design is modified how we'd like. Okay, so we've taken a bit of a look at the different one of these generative design samples. So what I'm going to do now is jump into a couple of the just generative design setups that I think are kind of interesting and maybe have some elements to them that might be useful for you to understand. And we'll just talk a bit about why they have the setups that they do. So I'm just going to close some of these outcomes. So I'm going to open up.
While Pete's just getting ready for the rest of it, another interesting thing that you can do with the T-Splines is actually it can aid in your kind of like preparation for, say, machining. So you could work on particular like overhang angles and stuff like that, and you could manually edit any parts that, say, you had inputted a certain angle in your overhang and you wanted to reduce that slightly in certain areas. It can really help with that.
Yeah, absolutely. So that's where, again, we have these different manufacturing constraints, and they are going to influence the design to be suited to a certain manufacturing method. But there's nothing to stop you manufacturing any of these designs with any manufacturing method. And especially when let's say you take a freeform generative outcome and you want to manufacture that with a process like CNC machining, for example. Let's say you really like an unrestricted outcome, and the large majority of it is something that you actually think we could machine this. But there are a few small parts that you want to make changes to for manufacturability. Again, T-Spline environment is fantastic for making those little edits, just to make, for example, as Pete said, get rid of overhangs and things like that. So I'm going to open up one of these next outcomes, and I'm going to open up this file called the Alcoa Bracket. So this is another similar to the GE bracket. This is an aerospace component, I believe. But what's interesting about this, we have this big yellow shape in the middle here. And this is something that we've not seen or spoken about so far. And this is what we call our starting shape. So when we look at our generative studies, if I go into my Explore window, we've seen how we have these different iterations. So we have this iterative process. If I open up one of these, so we can see if I drag back to certain iterations, we can see how generative design has come up with the final form of the design. So what our starting shape is going to do is it's going to define basically what our first iteration is. So we can see here that we're starting from this point here. Now, when you're first starting with generative design, I would recommend just don't worry or really think too much about the starting shape, because we absolutely do not need one. Unlike some other optimization tools, generative design doesn't need to be given a starting thing to work from. It can come up with ideas completely of its own. But there are certain cases where a starting shape can be useful or even essential. And this is an example of one of the reasons why a starting shape can be useful. So if we look, I've just hidden that starting shape with this kind of eye icon here. And if we look at this setup here, we can see that we've got a preserve region here that we're wanting to connect to these 4 kind of bolted connections. And we have an obstacle region here, which really quite significantly separates those 2 regions. So what we obviously want our design to do, as you saw in those outcomes, is connect and loop over the top here and come down on the other side. But there are certain instances when our obstacle geometry kind of is a big wall separating 2 bits of preserved geometry. Sometimes generative design isn't going to find this pathway that goes all the way around. And so it's going to look at your design space and it's going to think that, okay, you've cut off the preserved regions from each other. And so there's no way to connect these. It's because it hasn't been able to find this pathway. And so it's going to when you create a generative design study, if the preserved regions become separated from each other, then the study is going to fail. So we need to make sure that our preserved regions don't become separated. And so in a case like this, where generative design might struggle to find its way around this obstacle region, it can be really useful to create a starting shape. And all this starting shape here is doing is it's just telling generative design, it's helping it get around that shape, if that makes sense. And it's giving it a starting idea that makes sure that it goes the general right direction. So when you create these kind of starting shapes, you can see we've got quite a bit of detail in here, and actually none of that is really necessary. And once generative design has this starting point, it's kind of like it's not going to necessarily follow this starting point at all. And the final design it comes up with might look completely different. So if we look at, if we go back here, again, we can loop back through these iterations. We can see we gave generative design this kind of starting shape like this. And very quickly, so here we can see it's kind of kept lots of those similar ideas. But as we move through these iterations, you can see that all those elements of that design have kind of disappeared. And now this design looks very different. So when a lot of the time when people come to use generative design, we have this natural sense. We're so used to generating the design solution ourselves. And it can be quite hard to kind of give the algorithm that control. So often people will say, okay, I really know what design I want this to kind of look like. And so they think that by putting a starting shape that looks similar to the kind of design that they want, that's going to help them get to that final design. But actually, that's not the case. And generative design will very quickly come up with something that it thinks is best and will kind of get rid of that starting shape. So if there are elements of a design that we want in our final design, the best way to create those is with preserved geometry rather than with a starting shape, because then we know that that element is going to be retained throughout the design process. So the one kind of disclaimer to that I'd say is when we use generative design, we obviously, when we're exploring different outcomes and when we're looking at designs on the graph, the design that we see is this one here, which is our final iteration. But every single iteration inside of generative design is a potential design that we could make use of. And so one thing that we could do, if we wanted a specific, if we wanted to influence our design to be roughly similar to a starting shape like this, but we also wanted to use generative design to kind of come up with its own ideas, and we want some kind of hybrid between the two. Something that we could think about doing is taking one of these early iterations that generative design comes up with. So we can see at this iteration here, we've still got some of those design elements from our starting shape. So we've got this kind of geometry that kind of has this outer element, and it comes in, which later on is just, completely removed. But at these early stages, we can still see the kind of influence of that design in this outcome. And there's absolutely nothing to stop us taking one of these earlier outcomes and downloading it. And what generative design will be doing is essentially taking our design here and making intelligent changes to this design to meet the requirements we described. So we can see that the original design, again, if I just move myself slightly, we can see that our original design doesn't actually meet the factor of safety target for the load conditions that we've described. But what generative design has done is very quickly make changes which are essentially intelligent changes to improve the performance of this component by adding fillets to certain regions to better distribute the stress across the model. So this is kind of an interesting thing that we can sometimes do. Okay, so that was a little bit about starting shapes. Again, there's more detail we could go into here, but I think hopefully that's a really good overview of like what the starting shape does, and one of the reasons why we might want to use one, which is getting around these kind of awkward obstacle regions that sever our preserves. And another important note to make here is, so I mentioned that if we want to have an element in our final design, that a preserve region is better than the obstacle region. And that's absolutely correct. But we also need to be careful that we apply forces to every single one of our preserve regions. So if you remember, I said earlier that if generative design isn't able to connect all of our preserve regions, then the study is going to fail. Well, if we don't have any force acting on a preserve region, then generative design doesn't understand why it needs to be connected to the rest of the preserve bodies. And so what's going to happen is, if we don't apply a force, it's going to think, oh, perfect, I can take material away from that region because it doesn't need any strength. And eventually that region is going to completely separate from our design and your study is going to fail. So we should always have forces applied to our preserve regions. Okay, so we're going to look at, I think, one more of these designs. As I said, it's going to be a bit of a shorter stream this week. Maybe we'll look at two more, I think. So this is a design for a front loader. And what I'd recommend, so this design setup here is actually, there's a really great tutorial that we've put together, which is about users going between Inventor and Fusion 360. So if you're an Inventor user and you're interested in using generative design, I would highly recommend checking out the tutorial on the Fusion 360 adoption portal. If you go to like learning, there's a whole range of different kind of self-paced courses for everything inside Fusion 360, including generative design. We've got this tutorial series about working with Inventor files with Fusion 360. And we've got a really nice link put together between the two so that our designs automatically update as we change our design in Inventor. Our generative design study is going to change inside Fusion 360. And you're going to be working your way through this study setup here, which is for a front loader for some kind of construction vehicle, I believe. Yeah. The only other thing I'd say about this setup, and this is something where I think a lot of new users to generative design maybe make this mistake. You can see we've got 5 different load cases for this front loader. And so if I look at these different load cases, again, when I'm looking at the forces. It's really useful just to hide the obstacle regions, just to see what's going on. And we can see we've got different forces set up, different constraints. So you can see here I'm fixing about this constraint. Here I'm fixing about this region here and applying the force here. And here I'm applying this force here. And these different load cases represent the different ways that forces will be acting on this component. So if I want to create a new load case, the best thing to do is right click on an existing one and press clone load case. And what that's going to do is bring across all my loads and constraints from the first load case. And then if I want to make a change to this, so let's say I want to apply my force in a different direction, I can do so. And I was very, very quickly and easily able to set up this different load case. And one of the things I see newer users to generative design doing quite regularly is just not putting enough load cases into their design study. Again, when generative design creates its outcomes, what it's going to do is the only information it has to go on is the information that we give it. So if we want a design that is sensible, we need to represent all the different ways that we think our design is going to be loaded. And it's important to think not just about the kind of best case scenario, how it's going to be used in just normal life, but think about the worst case scenario. So think for a front loader like this. I don't know if we have any images of what this thing looks like, but basically this is like a kind of digger arm basically, and it's holding this big kind of digging pallet. So you could imagine as I lift heavy objects with this arm, we might think about the mass of those objects that this arm has to be able to lift. But we should also think about what happens if I swing around with those heavy objects. I'm actually going to start to get forces that act in alternative directions. So for example, not just in this plane, but also if I spin that around, in alternative planes as well. And we're also going to get moment forces as this is bent and twisted in certain directions. So we want to think about all those different ways that this is going to be used in reality and represent as many of them as possible. So I would always recommend people create as many load cases as you can. Think of all the different ways that the design is going to be used and create as many different load cases as possible. Okay, so the last thing we're going to look at is this file here. So this is back to the GE bracket that we looked at the start. And what you'll see is that we've got these 3 green ticks. And what we've done is we've run multiple studies. So up to this point, we've talked about setting up and running a generative design study. And that study has certain objectives. For example, we saw earlier, we were running an objective to minimize maths with a factor of safety of 2. But what might happen is we run that initial study and we think, okay, we've got a really lightweight design, but actually I don't need it to be quite as light as that. I want generative design to come up with design alternatives that maybe weigh slightly more, but increase the stiffness and mechanical structural properties of my design outcome. So what we can do is we can run multiple studies. And what we're doing when we do this is exploring multiple different design possibilities. And really we can think about a kind of solution space. And this space is all the different possible alternatives that we could come up with. So we can think about that scatter plot graph we were looking at where each dot was a design. And what we want to be doing is exploring all the different design possibilities as effectively as possible. So we want to create as many different dots that each have different advantages or disadvantages against each other. And one way that we can do that is by running multiple studies. So for example, if I take this study here, and this study consists of all my preserved geometry, obstacle geometry, objectives, manufacturing, materials, etc. I can right click on that study and select clone study. And what we've done is we've now created this new study. I can rename that to anything I want. If I call that new study. And this is just an exact replica of the existing one, so not really that useful. But what I might then do is say, okay, so we ran an objective with minimized mass and a safety factor of 2. And we came up with a design that we really liked that weighed, let's say, 100 kilograms. But how about we come up with a design that doesn't weigh quite as much as that? We're in pounds, and I don't know what that means, I'm afraid, because I'm European. But we should be able to type in kilograms. Change the study. So let's say that, as I said, we came up with that design that weighed 100 kilograms, and we now want to explore what this would look like if it was 150 kilograms instead. So it's not quite as light, but maybe our design is now going to be better performing. So we can set this up with maximized stiffness and with that design properties. We might also come up with a simpler design. So sometimes when you see generative design outcomes, you get these really organic freeform shapes that are theoretically optimum, but sometimes they don't look like they've almost had too much mass taken out, and that's going to make them harder to manufacture, for example. So again, this is an interesting way we can still come up with optimum designs, but often we're wanting to balance performance against things like cost. So by running multiple studies is a great way to explore those different possibilities. So what you can see here is that we have run a couple of different studies with different objectives. So, okay, sorry, that was the wrong one. So if I open that one up. So we've run a objective with this objective. Run a study with this objective. So a mass target of 0.6 kilograms. And we've run a mass target of 0.8 kilograms. So now if I explore the outcomes, you see it gave me that dialog box because I created a new study, and it's just asking me if I want to generate outcomes for that study, which I don't want to do. And if we go into our different designs, we can see we can filter by study. So if I go here. So these are the design outcomes that were minimized mass. And what we did is we specified with a mass target. So we specified a mass target of I'm a little bit confused here as to why. I think I might have confused myself by changing these units. If we turn those back. Okay, so here we're looking at the outcomes from our study with a mass target of 1.5. Here we're looking at our outcomes from a study with mass target 1.8. And here we're looking at our study with a minimized mass objective. And what we're going to see is that these different studies are going to give us different possibilities and outcomes. So what I would be expecting to see would be that our mass is around the target that we're aiming for. So in this case, what's going to happen is we're going to specify a certain mass target. So in this case, we specified a mass target of 1.5, and I'm guessing that was in pounds mass. And when I look at my design here, you can see that we're above that target. So when we set a maximize stiffness target, we've actually got two different objectives. We want to, first of all, make sure that our design remains strong enough. So we've got a safety factor of 2 that we need to ensure that this design retains. And we've also got a mass target, in this case of 1.8. And that mass target is an objective that we want to hit. And we're not going to go below 1.8 as our mass target, but we're also not going to go below 2 for our safety factor. So in this case, our design, we can see we've started at a certain mass, and we've slowly reduced mass, aiming for our mass target of 1.8 pounds mass. Now, in this case, what's happened is that before we reach that mass target, we're going to hit the safety factor limit. So for this material, the mass target that we specified is going to be too low to reach. So what generative design is going to do is it's going to try and get as close to that mass target as possible while still maintaining its safety factor. For a different material where we're able to bring our design all the way down to that mass target, or if I'd, for example, specified a mass target of 4 pounds mass, then what would happen is when we reach this mass of this mass here, we wouldn't continue to take material away or continue to try to reduce the mass. Instead, what we'd do is you'd see your design kind of continue to iterate, but it will hover around this mass, and it will maintain the mass at this objective. And what it will do is kind of go up and down slightly with each iteration, but it will try to stick around this mass of 4, and it will reduce the max displacement and try and come up with a design that is as stiff as possible with those objectives. So this is one of the reasons why we would run multiple studies. Again, multiple studies can be used to explore things like different forces acting on a design, or if we want to change, for example, our obstacle or preserve regions and see how that influences the designs we get out the other side. Okay, so as I said, it's been a bit of a shorter session this time, but hopefully that's been a useful look for everybody at what is inside of these generative design samples. And what I'd highly recommend you all to do is, if you're interested, go and take a look at these yourself. And you can open up your Ready to Explore outcomes, try out these different tools we have to see the different design possibilities. You can open up the generative design outcomes, and you can see some of the things that generative design comes up with. And hopefully this will give you an idea for some of the different applications for generative design. So you can see here, for example, we're using generative design to create an end effector for a robot. And again, you'll be able to see, if we drag this back, what we used as our preserved geometry, what we used as our obstacle geometry, the T-spline shape that we get out the other side for this setup. So I think we're going to end things there. I'll jump back to here. But yeah, thanks so much again for joining, and I hope that's been a useful look for you about how those generative design samples look. As I said at the start, we also have samples for other things in Fusion 360. So for example, electronics and simulation. So if you're interested in any of those other topics as well, then check out some of those samples as well. So fantastic. Well, thanks again for joining us, and we will see you next time.
Yeah, hope everyone has a good week. We might not be back for a few weeks, might we, Pete? We've got some other stuff coming up, but we will be doing some more of these. I think we're going to focus more on some kind of more on the art of design rather than maybe the engineering side of it. So come back in a couple of weeks and we'll be back to teach you guys some more cool stuff.
Yeah, absolutely. I think next week we won't be streaming, but hopefully in the future. So as I said, we have this hope to do like a session on rendering. So we're going to look at setting up renders for generative design outcomes. We've got some other ideas as well, but if you have any suggestions for what you'd like us to look at, particularly anything around generative design, please leave messages in the comments of the video, and we'll definitely be keeping an ear out for different suggestions. So, yep, thanks again for joining us, and we'll see you again soon.